Hello everyone, welcome to Grainchat. Today we look at process of grain cooling. We are Joe Sontag and Hoàng Uyên from Sontag Concern.
We welcome again the storage expert, Dr. Claus Braunbeck from FrigorTec in Germany. Welcome, Klaus.
Hello.
Hello, Dr. Claus. I have a question for you today. Some customers face a certain confusion about grain cooling as is used along the term aeration, cold storage, and ventilation. Dr. Claus, please bring clarification to the confusion.
Thank you very much for the invitation and the interesting topic. I also experienced this confusion. The main reason is the terminology of cooling. No doubt that means a reduction of temperature, but it doesn't refer to the process of grain cooling.
So how should that be understood?
If a warm grain is ventilated with colder ambient air, it is cooled. But that isn't grain cooling. Grain cooling refers to chill the grain lower than the ambient temperature. This is a significant difference, which is only achieved by a process which is independent of the weather.
That sounds too specific, as lowering a temperature is cooling.
Indeed, at the first sight. But the term grain cooling is not only focusing on the reduction of the temperature, but covers more as a process to preserve the grain like refrigeration.
I got it. But what makes the difference of grain cooling and cold storage, as you mentioned the refrigeration?
At a cold storage, the goods are placed in a cold atmosphere without adjustment of the relative humidity. The bulk cools at its surface, being in contact with the cold. But inside the bulk, it cools only by conductivity through the bulk, which is slow and ineffective.
That's clear. So what about grain cooling?
Grain cooling is using forced air for cooling, which is conditioned to a specific temperature and relative humidity, and then blown through the grain to reach each single kernel directly. That is fast and effective, and the heat of the single kernel is released quick.
Yeah. That's an essential difference of effectivities. You mentioned another important condition which is significant for grains, the relative humidities. What can you tell about it?
Grain is hygroscopic, and high relative humidity will affect its quality. At a cold storage or during ventilation, the relative humidity is not controlled. However, grain cooling process fully controls the relative humidity during the operation. This assures the quality of the grain at any time.
What else does it mean for the grain storage?
The adjustment of the relative humidity avoids uncontrolled moistening or drying of the grain. Particular low relative humidity is avoided, unlike aeration, which causes moisture loss and thus weight loss of the grain, which is in the end an economic loss. In addition, it can be crucial for grain like paddy if lower moisture content causes quality loss during processing.
So how does grain cooling cope with the inhomogeneous moisture in the bulk?
The control of the relative humidity allows the equalization of the moisture content inside the grain bulk. Moist grain will release and dry grain will take water to reach equilibrium. An essential difference for grain with various kernels like corn or grain which must be carefully be processed like paddy.
Amazing. I couldn't consider that cooling is not only related to the temperature, but to relative humidity and moisture content of grains as well. Maybe we should take a deeper look into this in one of our next Grainchat series. For today, thank you very much for your time, Dr. Claus.
My pleasure. Thank you for the Grainchat.
Thank you, Klaus, for joining us again.
Dear audience, please feel free to contact us if you would like to address another topic of interest or send us your comment about today's chat. Thank you.